Hello everyone, my name is Leslie Elizabeth Pond. In this video I'm going to talk about token separation using Lex tool. Now Lex is a stimulator which helps to do a lexical analysis. It has three parts. First is declaration, second one is translation rules, and third one is auxiliary procedures. Now in the declaration part we actually declare the variables and the regular expression, and then in the translation part we actually give the rules, like the rules or definition, like how a pattern, if a pattern matches, etc. not. And then finally in the auxiliary procedure we give the main function where a y/lex function will be called and the whole procedure will get started. So the algorithm for this program is to first create a Lex specification file program which extension will be .l, and then include the necessary header files. Then finally declare the necessary variables, constants, and regular definition. And then write regular expression and corresponding actions for identify keyword, number, operators, and punctuations. And then finally write the main function and call y/lex function. So this will be the input. You can see over here int a comma b comma c, and then c is equal to a plus b into 20. Now in the output you can see it has been divided into tokens. It has been printed. And int is a keyword, so keyword comma int, and a is an id, therefore id1 comma a. So similarly we're gonna print it. Now the question set is to first perform a lexical analysis on input program for a subset of language, and then perform the token separation, and finally count the tokens in a given input size. Okay, so this is my coding. You can see, as I said, the very first part, this is the declaration part, is purple color lines. So here I'm actually declaring, here this place is actually declare variables and or the regular expression. So these are the four regular expressions that I have been declared. First one is the operator regular expression, which will include multiplication sign, division, plus, minus, percentage, that is modulus, and equal to. And then for letter, I have declared an regular expression that is small letter A to Z and capital letter A to Z. Then I have digit, that is 0 to 9, and finally the punctuation marks, that is comma and semicolon. So that was a declaration. That's no need of declaring any variables over here. And you can see over to end the declaration part we're giving two percentage signs. So this is how we're gonna end the declaration part. Now after that the translation rule part starts. So here I'm going to give all the rules which my program has to follow. That if here the input which will be in the y/y test will be compared and see if any of my y/y test matches any of these rules. So the first rule is to check the type or the data type to find the keyword. So that is int or float or double or short or char or string. If it is so, then I'll print keyword and whatever the value is. So this is written in C language, that is keyword $s, the type, data type, and then I'm ending it, and then I'm going to print the y/y test. In the y/y test I'm going to have the input, whatever input has been given by the user. Okay, this is a y/y test will have the value after the token separation. So after the token separation that will be a value in y/y test, and that will be compared with my rules. And second rule is I'm going to check if it is a variable or not. So it is identifier or not. For that it can start with a letter, and then it can have combinations of letters or digits. So that's why I'm giving this starting as letter, and then the combination of letter, that is letter or digit, and numbers. So any numbers of letters can count. So if this is a condition, then it will print ID, and then the data type and the y/y test. Then the third is to check if it is a number. So the number should always start with a digit, and then n number of digit is possible. That's why digit inside the brackets, curly bracket, and then given this closure to say that n number of digit is possible. And if this is a condition, I'll print num, then the data type, and then the y/y test, and then finally it is punctuation. So here you can see if it's punctuation, if it matches to anything like comma or semicolon, it will print punctuation. And one more thing, operator, if it's an operator, that is plus is equal to minus anything, it will print O. And finally I'm closing this translation rule part by 2 percentage. And then finally I'm calling the main function. Inside the main function I'm calling the y/lex function. So here the y/lex function actually starts the whole thing, and then you can see over here I'm inside the main itself, and the main I'm calling the y/wrap. So while my wrap function is called to end a particular program. So if here in this value in this program we will get 2 1 as output, that means the function or the program has been successfully executed. So this is the program. Now let's go to the output of this program. So here you can see this is the output of the program. Here I'm giving I have first of all compiled the Lex program and I'm converting it into a C program. So for that I'm going to do is lexpg and the name of the file .l. So once I execute this lex program name, it will be converted into a C program. Now I have to compile this C program. So the output of this this conversion will be a file with an extension whose name is lex.vyva.c. Now I want to compile this file. So next time, for now compiling the whole C program file, I'm going to give the command that is cc space lex.vyva.c. So when I get this do this command, the program will be compiled, and to see the output, we're going to give a/a.aut. Okay. Finally, after this is the output, this is the input of my program, given int a comma b comma c. So you can see it has did the token substitution, and you can see int is a keyword, so it printed keyword int, and then a is an id, b and c is id, and then punctuation mark is given by punctuation comma, and then you can see over here this is another output input, that is a is equal to divided by 3. So a is an identifier, is equal to the operator, number is 20 is a number, division is the operator, and again number, then finally the punctuation semicolon. So this is my output. So this is how we do token separation using Lex. Thank you so much for watching this video.